Okay, so we're going to talk about the quadratic formula today. The first thing we're going to do is we're going to actually prove it. And we're going to start off with the most general quadratic equation that there is. And that's this one. So let's say we have ax squared plus bx plus c equals 0. So we're going to start with a general quadratic equation. Okay, and we're going to do some algebra on this equation, complete the square, basically what we learned yesterday, so that we get a general equation that works for any quadratic form equation. Okay, so first thing, we have to establish a few things about this these numbers a, b, and c. They could be any real numbers. So basically, I'm going to throw some symbols at you. An upside down a, that means for all. For all ABCs, A, B, and C, which are parts of, this funny looking E means elements of real numbers. So all we're really saying here is A, B, and C could be any type of number you could think of. Positive, negative, rational, irrational, you know. So it could be any number you want. And another very important thing, A cannot be 0. Because if A is 0, what happens to our squared term? Yeah, it goes away, right? 0 times anything. And then we'd have a linear equation, and we know all about those. So A can't be 0. Okay, so here's what we're going to do. We're going to perform a step, and then we're going to explain what that step is. So let's look at this first step. Okay, so the first step is we're going to divide everything by A. So if I divide by A, I get x squared plus b over a times x plus c over a. And what's 0 divided by a? Just remember, a is any number. So what's 0 divided by any number? 0. So that's 0. And what did we do there? I'm going to just write the step over here. Divide by a. These are the steps you really want to make sure you understand. So that's the first thing we did. I guess we should number them. This is step 1. Okay, so now remember when we're completing the square, this is just a number. This is just a constant, right? We got to move it over to the other side. So what happens to plus c over a if it goes to the right side? Yeah, so that's step 2. X squared plus b over a x equals negative c over a. That's step 2. And all we did there is move c over a to the right. Oops. To the right. Where is my... So we're just using all the moves that we've been doing to complete the square. All right, so now here comes the step. We usually call it uh, completing the square. We need to add something to both sides that'll give us a perfect squared binomial, that will factor into a perfect square binomial. And that has to do with this one here. Remember what we needed? We need half of this and squared. So this is going to look like this. We are going to do step 3. It's going to be x squared plus b over a x plus, I'm going to write this one in red so we can tell this is the new step. It's going to look like this. B over 2a squared. We're adding this to the left side, which means we also have to add this to the right side, equals negative c over a, which we had before, also plus b over a squared, b over 2a squared. Yeah, remember we had to, when we were completing the square, we had to divide the number in half and then square it. Yeah, it's going to work with that. Yes. You're going to see that it is going to generate that denominator of 2a. Okay, so basically, what did we do? Add b over 2a squared to both sides. All right, so let's see what we have now. We have the left side, which is now can be factored, and then this mess, which we'll have to fix. Okay, but the left side, we did all this work so that we can factor this into a perfect square. Okay, and remember what we want to take. We want to take the square root of x squared and half of b over a. And that's going to be our squared binomial. And we got a plus, and we got a plus. So step 4 is going to look like this. It's going to be x plus b over 2a squared. So all of this became this. Okay. And then on the other side, we still have the negative c over a, all of this stuff. Okay. So let's just go ahead and write that down. Equals, I'm using the wrong pen, negative c over a plus b over 2a squared. So what did we do in this step? Yeah, we factored we basically factored the perfect square. This turned out to be a perfect square. Binomial. Okay. All right. So now we have to do a couple other things. Now we got to deal with all of this mess on the right. So first thing I notice is over here on the right hand side, we have something that's squared. Let's square it. So what do I get when I square b over 2a? Well, what's the numerator going to be? B squared. What's the denominator going to be? 4a squared. So let's just do that. Let's just square that. Let's write down what we get. So step 5, we're going to still have x plus b over 2a. We're basically just cleaning things up so then we can take the square root. and we get negative c over a. We're going to leave that alone. Plus b squared over 4a squared. We basically squared this. So all we did was simplify something. So let's just say simplify b over 2a squared to b squared over 4a squared. Okay, that's all we really did. Okay, so now we have a fraction, right? We have a fraction on the right-hand side, and one denominator is a, and the other is 4a squared. I have a on as one denominator, 4a squared for the other. I'd like to add this together, but I need a common denominator. So it's easy to change a into 4a squared so that I would have 4a squared for both. So what would I need to multiply a by to get 4a squared? 4a. But the catch is if I multiply the denominator of this by 4a, I got to multiply the numerator by 4a because it has to be 1, right? What's 4a divided by 4a? 1. I want to multiply this by 1 so I don't change the value. Yeah. So that's what we're going to do. So step 5, it looks 6. Step 6. This stays the same. X plus b over 2a squared equals negative c over a times 4a times 4a. Okay, and then we still have plus b squared over 4a squared. And the reason we're doing this is we want a common denominator. Okay, we are going to get a common denominator. Okay, so multiply by 4a over 4a to get a common denominator. Okay. So let's multiply the numerator and denominator and see what we get. Okay. So this is what we're going to get. So if we multiply c by 4a, what do we get there? 4ac. And then we're in the bottom, what's our denominator going to be? 4a squared. Yes. Okay. So this is step 7. This stays the same. X plus b over 2a squared. And we're just going to put everything under one denominator. But for it to look a little neater, since our denominator is 4a squared for both, I'm going to write it this way. B squared take away 4ac all over 4a squared. So all I did was I recognized that this numerator is 4ac, and it's here. The denominator is 4a squared. It's a common denominator, so it's there. And since this is positive, I put it in front. So it becomes b squared minus 4ac all over 4a squared. Okay? And it looks like it's real messy right now, but it's going to clean up in a little bit. Okay, so let's write down what we did. So yeah, just combine. So let's just say add left side. All we did is add, I'm sorry, not the left side. We added the right side. Let's change that to the right side. And I can't find my, here we go. Add the right side. Add the right side. All right, so now we're getting close. We cleaned up everything to the point where we can take the square root of both sides. So we're going to square root the left side and the right side so we take care of that. Okay? So this is step 8. We're going to square root both sides. So inside of here we're going to have x plus b over 2a squared. And then we still have to do that over here on the right side. So equals, since the x is over here, we have to have plus or minus over here. Plus or minus all of this. B squared minus 4ac all over 4a squared. And what do you notice about 4 and a squared? Well, yeah, but what do you notice about just those numbers in themselves? The number 4 and a squared. Aren't those perfect squares? Yeah, that's going to be helpful in a little bit. Okay. So, okay, what did we do? Square root both sides. Okay. Number 9. So what can we do once we square root both sides on the left side? Yeah, take out the square, basically. The square root and the squaring cancels. You're just left with x plus b over 2a and then equals plus or minus. All of that stuff. We can't really do anything with this yet. B squared minus 4ac all over 4a squared. Okay. So remove the square root. On the left. Okay. Just a few more steps left. Number 10. All right. So we got rid of the square root. Let's look at this right side. Let's clean this up a little bit. Remember I told you to notice that this is a perfect square? So we're going to split this up into 2 square roots, the numerator and the denominator. So this stays the same. Oh, can you open the door, please? And then we have a square root for the numerator. And a square root for the denominator. There it is. So all we did is split it up into two square roots for the numerator and denominator. It is. This is how thorough you have to be when you're proving something. Can't leave it to mystery. Okay. So basically, you could say you split it up, or you split up both, or you square rooted both separately. And why did I do that? What can I do in the denominator? Yeah, cancel the square root. 4a squared becomes 2a. So let's go ahead and look at that. So step 11, oops, I'm using the wrong pen. X plus b over 2a equals plus or minus the square root of b squared minus 4ac over 2a. Okay. And there we just basically simplified denominator. And we're almost there. If you look at the formula up there on the sideboard, you see that we're almost there? Yeah. We got the b squared minus square root of b squared minus 4ac. I got 2a. The only thing I have to do now is the following. Bring this over. I got to bring this over here. Right? Well, let's do that. So this is step 12. And then x equals, if I bring plus b over 2a to the other side, what does it become? And we're oh so close now. Look at what the formula looks like and look what I have. Yeah. So let's write down, we just moved b over 2a to the right. Okay. And what do you think the last thing we can do to make this look like that? Yes, Jaime.
Both of the numbers on the right have a denominator of 2a, so you could just put it all into someone.
Yeah, we have a common denominator. So we could just put it under that common denominator. And we get x equals negative b plus or minus square root b squared minus 4ac all over 2a. And that is the quadratic formula. And basically, we just use the common denominator. Now, would I expect you to be able to come up with this on your own? No. But do I expect you to follow the steps and as we did it, you say, oh, yeah, that makes sense. I understand that. We've learned enough now that this is something I can follow. Yes. And that's really where I want you to be. If we did all this and it wasn't like a total mystery, then you're in good shape. Yes. Yeah. Okay. Now, one of your assignments today is going to be, hopefully you took all these notes. I'm going to give you all of the steps, and then you're just going to have to give me the reasons, the part in purple. Okay? Um, all right. So what we're also going to do is we're going to use the quadratic formula for two problems. Okay? So I'm all filled up here. I'm going to have to go to the next page. You guys ready? All right. Here we go. We just write these on the back. So we're going to use the quadratic formula now. Okay. So we're going to solve 4m squared plus 4m plus 1 equals 0. Okay? And the first thing we want to do is identify our a, b, and c values. Okay, so a equals 4, because remember it's a coefficient of this quadratic. B equals 4, and c equals 1. So it's basically the coefficients of the quadratic term, the linear term, and the constant. That's your a, b, and c's. Now, let's write down the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2 times a. Okay. And the first thing we want to do, especially once you're first learning how to use this, just put the numbers in. Replace a, b, and c in the formula with those numbers. So let's go ahead and do that. So this is going to give me b is 4, so this is going to be negative 4 plus or minus the square root of 4 squared minus 4 times a, which is 4, times c, which is 1. Notice I'm using parentheses. Get in the habit of doing that for these type of problems. All over 2 times 4. Okay. So all I did here, just put the numbers in. Now let's go ahead and start simplifying whatever we can. Okay. So I'm going to do that in this next step. So I can't do anything with negative 4 right now. Just leave it negative 4. 4 squared, I know that's 16. So there goes a 16. And now for the next part, I'm going to multiply negative 4 times 1. Negative 16. All over 2 times 4, so that's 8. Okay. Well, simplify what's inside the square root. 0. So now I get negative 4 plus minus square root of 0. That's going to be one solution, all over 8. And that's one solution, right? Because we know that yeah. I'm going to get negative 4/8, and that simplifies down to negative 1/2. Okay, so I got negative 1/2 as the answer, and that's it. Okay, so we know that because we learned that square root of 0 would give you one solution. In this case, it's negative 1/2. All right, any questions? We'll do one more. Number 2. Okay, so for number 2, we've got 12r squared minus 5r. Oh, I'm sorry. Change that to minus 9r minus 25 equals negative 4r. Yeah. So if you have something other than 0, you got to clean it up. So I'm going to add 4r on both sides. Now it's 0. So this is 12r squared minus 5r minus 25 equals 0. And now, once it's equal to 0, let's figure out our a, b, and c values. A is 12. Okay, so we got 12, negative 5, and negative 25. Okay, so let's go ahead and plug all that in. X equals, well, we want negative b, right? We want negative b. And then we have negative 5 for b. So I'm going to write it this way. Negative 5 plus or minus the square root of b squared. But my b is, so it's going to be negative 5 squared minus 4 times my a value, which is 12, times my c value, which is all over 2a, which is going to be 24, but I'll just leave it this way right now. So all I did was plug in numbers for the quadratic formula. Now I'm going to simplify. So what can I do with this? Yeah, that's just 5. Plus or minus. Yeah, negative 5 squared is 25. Minus. Okay, we got to be careful here. I got a negative here and I have a negative there. Yeah. But what's a negative and a negative going to give me? Positive. So it's going to become plus. And it's because I have two negatives. And then, yeah. So that's going to give me what? What do I get when I multiply that? Isn't that 1,200? Yeah, because think of it this: 4 times 25 is 100. 100 times 12 is 1,200, all over 24. Okay, So now we have to add 25 and 1,200. So 5 plus minus 1,225 all over 24. So now here's the big question. Is 1,225 a perfect square? Take the square root of 1,225.
35.
It is. It's 35. If it would have been like a decimal number, an irrational number, leave it as a square root. But I think all your work today is going to work out nicely. So this becomes negative 5 plus or minus 35 all over 24. So we can split this up into two answers.
Isn't it positive 5?
Huh?
Positive 5?
Oh, positive 5, yes. My bad. So it's used to him. We're going to split this up into two answers. 5 plus 35 over 24 and 5 minus 35.
So then we just simplify them into whole numbers or just keep it as
Fractions. Yeah, these are going to be fractions, right? Because we're going to get 40 24ths. Or negative 30 24ths. But we better simplify them to lowest terms. So this would be 5 thirds, right? We can simplify that. So this becomes 5 thirds. But then you could simplify that to negative 5 4. So there's your two answers, 5 thirds and negative 5 fourths. I know. But this will get you the answer to any of them with no factoring, no completing the square. You just plug in numbers and you have to just be careful as you go through the formula. All right.